Okay, this is chapter 6 homework. First problem, number 59, says, divers in Acapulco dive from a cliff that is 61 meters high. So we've got this cliff that's 61 meters high. And the rocks below extend outwards for about 23 meters. What is the minimum horizontal velocity the diver must have to make sure that they clear these rocks? All right, so I always do this X and Y information. So we have initial velocity in the X is what we're looking for, which is the constant velocity in the X, so I'll just call it velocity in the X. Distance in the X we know we need to clear is 23 meters. Time is question mark. So we have to go to the, because we only have one of these three variables, we're going to have to go to the vertical information, try to do some work to get one of these variables, specifically time. That's going to be typically what we do. So we have initial velocity in the Y is 0 if he jumps from a vertical. Final velocity in the Y we don't know. Acceleration in the Y is negative 9.8 meters per second squared. Initial distance in the Y is 61, and final distance in the Y is 0. We can use that to find time. Let's write down some equations and see once if we can get one of these to work off our formula sheet. This equation off the formula sheet would help us find time. Initial velocity is 0. Initial distance is 61. Final distance is 0. So just plug in for what you have here. Negative 9.8 times time squared. So you're going to solve this equation right here for time. And when you do that, you get about 3.53 seconds. So 3.53 seconds. The nice thing is that's the same for the horizontal, 3.53 seconds. So I can then just use our simple velocity equals distance over time now to find the velocity. It's 23 divided by the 3.53 seconds, and that gives me about 6.5 meters per second in the X direction is what you have to clear these rocks. All right, let's say that you accidentally, sorry, I did 59 first, but we'll go to 51 now. It says you accidentally throw a car keys horizontally at 8 meters per second from a cliff that's 64 meters high. So you got this cliff that's 64 meters high, and you're going to throw some keys at 8 meters per second off. And the question is, how far from the base of the cliff do the keys go? All right, so what we always do for these is we always write down the X and the Y information. Okay, so for the X information, we were given the speed and the X. And by the way, there's always one speed for X. Just, you call it V sub X. You can even put a bar over it to represent average speed if you want, because the speed in the X direction never changes because we never take into account air resistance. Therefore, there's no force in the X direction and no acceleration. So the initial speed in the X is 8 meters per second. The distance in the X, we don't know how far it's going to go in the X. So I'm going to call that question mark. That was what the question asked for. So maybe circle that because that's what you're looking for if you want. Time, we don't know as well. So we're going to go to the Y information then. We have initial velocity in the Y, which, sorry, that's not average. Initial velocity in the Y is 0 because it starts off vertically. It doesn't start off moving at all. It only starts off moving horizontally at first. Okay, final velocity in the Y is, I don't know. Acceleration in the Y is always average, and that's always negative 9.8 meters per second squared for free fall problems. Initial distance in the Y is 64 meters at the top of the cliff, and at the bottom, it's 0. Now, we want to find most of these, if not all of these problems that we do where you're trying to find like something in the horizontal direction. When you're not given enough information, what you want to do first is find the time, because the time is the same for the X and the Y. So that's kind of your link to getting another piece of missing information in the X direction in order to solve the problem. I'm sorry, this should be distance final. I don't know why I had a sub-0 there. All right, so what we want to do then is we want to look for a relationship between initial velocity, acceleration, distance, and time, because we know that we want to find that time right there. That equation is on your formula sheet as distance final equals distance initial plus initial velocity times time plus 1/2 average acceleration times time final squared. Now the initial velocity of the Y is 0, so that whole term drops out. The final is 0 for distance. The initial distance is 64. And then it's 1/2 negative 9.8 for the acceleration, and the time is what we're looking for there. So we're solving, this is exactly like problem 59 for the most part. We need to find this time right here, so we're going to subtract 64 from both sides. We're going to divide by negative 4.9. And we're going to take the square root of that answer, which gives us a time of 13.1 seconds. Is how long
you have to square it.
Oh, I'm sorry, I got to square root that. I'm sorry, I forgot to square root it, so it's 3.6 seconds about that it's in the air for. Now that can be written in the x information as well, because the time is the same for both of them. So now we can find the distance once again, because distance is velocity, velocity is distance over time. Well, we have the velocity is 8, we have the time is now 3.6, so just multiply both sides by 3.6, and that gives you a distance of 28.9 meters. So this would be 28.9 meters is your answer. Next one says, toy car runs off the edge of the table that's 1.225 meters high. The car lands about 0.4 meters from the base of the table. How long did it take to fall? So once again, I always, just for sake of being organized, because I know the brain retains stuff in an organized way better, initial velocity in the x, or just velocity in the x because it's average, is we don't know. Distance in the x goes 0.4. Time in the x, we don't know. Vertical information, and we have initial velocity in the y, we know it has to be 0 because initially it's just traveling horizontally on the table, it can't move up or down at all. Final velocity, I don't know what it ends up, how fast it ends up going at the bottom. So we'll just call that 0. Acceleration in the y, negative 9.8 meters per second squared. Initial distance is the initial height, 1.225 meters. And final distance is it hits the ground, so 0. And the time we don't know. So this is a very similar problem to the last two problems we just did. We want to find the time. All right, so let's try once again our distance final equation equals distance initial plus initial velocity times time plus 1/2 average acceleration times time squared. Final distance is 0. Initial height is 1.225. This term drops out again. We have 1/2 9.8, negative 9.8 times t squared. So we'll move this over to the other side again. Negative 1.225 equals negative 4.9 t squared. Divide both sides by negative 4.9 and take the square root, and you get. So it's only in the air for about 0.5 seconds. We can then enter that in right here, and once again do velocity equals distance over time, where we have 0.4 over 0.5, which gives us. Actually, I'm sorry. That's all they wanted for the first question. How long did it take the car to fall? That's the question for part A, the answer for part A. And then how fast was it going? That's the question they want for part B, which is 0.4 over 0.5, which would give us 0.8 meters per second. So there's part A, and there's part B. So next one's 57. It says pitch ball is hit by a batter at a 45-degree angle. So we have a ball that's hit at a 45-degree angle, and the fence is 98 meters away. If the fence is the same height as the pitch, find the velocity of the ball when it left the bat. So we want to find out the overall velocity of the ball as it left the bat this way. That involves both the x and the y. So this is a tough problem. So let's write down everything we know again for the x and the y. In the x direction, we don't know. I'm going to draw a little diagram here where I'll do this in green, where I'll make a right triangle out of this, and I'll call this the initial velocity in the x, and I'll call this the initial velocity in the y, because that is the component of this vector that would be the initial velocity in the x, and that's the component that would give the initial velocity straight upward. So for the initial velocity in the x, I don't know what that is. All right. The distance in the x I do know is 98. The time I don't know what that is either. So then for initial velocity in the y, I don't know what that is. But I do know that they're equal, because if it's a 45-degree angle, these have to be equal, right? Because we know it's an isosceles right triangle. So I know, for what it's worth, I'll write that down. That has to be equal to the initial velocity in the x. Then the acceleration of the y is negative 9.8 meters per second squared. Initial height, I don't know what that is, but I do know it's equal to the final height, because the ball lands back on the ground. So then the time, I don't know what that is either. All right, so once we have everything written down, we're going to have to set up a system of equations. So from the first information here, we have velocity equals distance over time, which would be velocity equals 98 over t. I'll write that, I'll just leave it like that for now. That's one equation. So I'll circle that one. Second equation we're going to have is from the vertical information. We have distance final equals distance initial plus initial velocity times time plus 1/2 the average acceleration times time squared. So that would be, these are equal. That gives you 0. Initial velocity in the y I'm just going to call v because all these velocities are the same. So I'm going to call them all just v now. Right? Horizontal and vertical are the same because it's an isosceles triangle. Negative 9.8 goes in for acceleration. And so I have two equations now. Here's my second one. Let me simplify it. We call this negative 4.9. And there's my first one. So I have a system of equations. This is a really tough problem, but we'll substitute. We get 0 equals 98 times t over t minus 4.9 t squared. These t's cancel. I can subtract 98 from both sides. So all I need to do is divide both sides by negative 4.9 and take the square root, which gives me a time of about 4.47 seconds. So that's my time, and the question was, find the velocity of the ball when it left the bat. Well, now I know this is 4.47, so I can find that initial velocity. Just do velocity equals distance over time. So do 98 divided by that time, you'll get the velocity here, which is about 21.9 meters per second. Now that goes here, 21.9. Whoops, 21.9 meters per second. But it's both the horizontal and the vertical because we know that they're the same in this case. Set at a 45-degree angle. So we can just do the Pythagorean theorem now. 21.9 squared plus 21.9 squared equals c squared. A squared plus b squared equals c squared. And then we can solve for c by taking the square root of that quantity right there, which gives us the overall velocity. I'll call it v vector to represent it as an overall vector. Or I could call it the magnitude of v, however you want, whatever you want to call it. It's the overall velocity, which is approximately 31 meters per second total. And the last question says, an airplane traveling at 1,001 meter above the ocean, so this is 1,001 meters above the ocean, and it's traveling at 125 kilometers per hour. I'll make that 125,000 meters per hour, and then let's get that in meters per second because we always want to be in meters per second, mainly because our acceleration is in 9.8 meters per second squared. So we got to be in meters and seconds, otherwise these problems aren't going to work for us. So let's convert this. There's 3,600 seconds in 1 hour, so let's do 1 hour is equivalent to 3,600 seconds. And that way we'll convert this to meters per second. So we're going to use 37.7 meters per second for our initial velocity. So let's go ahead and fill out all 34. All right. So x and y information. We have the initial velocity in the x is 34.7 about meters per second. Final velocity in the x should be the same, right? So we just do average acceleration in the x. Distance is we don't know. Time we don't know. Now let's fill out the y information. I'm going to pause and fill this out because I'm running out of time on this video. Here's all the variables. Go ahead and pause and write these down if you want. This is the equation we're going to use. So let's go ahead and plug in what we know. Similar to the other problems we've been doing, when you plug this in, this middle term drops out. Now we're just solving for time. So you get about 14.3 seconds if you solve that for the time that it's in the air. All right, so we got to answer the question now, which was, so the time is 14.3. That answers question A because that's how much time should be dropped before the box gets overhead. And then we have to find that distance for part B that it asks. So let's just do velocity equals distance over time. Velocity is 34.7. Distance is what we're looking for, divided by 14.3. So just multiply 14.3 over both sides. This gives you about 496.2 if you do that meters. That's the horizontal distance that is between the plane and the victims. All right, I hope this helps.